Hey, welcome. Good to see you. So, slope warping. Whoa. Just kind of rebalancing and tilting our character based off the angle of the floor that she's on. And right now I have it a bit exaggerated so that we can see it as the example, but it's very cool. And one of the things I really like as part of the player experience is that the character reacts to the environment that they're in. And that's what we're doing here. So we're saying if my character is on an incline, let's get that information and pass it to our character and manipulate how they're standing. So let's walk through that. Now, there's probably going to be a lot of ways to set this up. Right now, I just switched to a control rig setup for this, and I'm passing my variables through the blueprint to the animation blueprint, and then finally to the control rig. So let's take a look. So if we come over to our blueprint, this is the function that's being called on an event tick, I believe. Let's just check. So we just have to know all the time where are we at. So that slope trace is being called in the event graph. And it's pretty messy. This is a ongoing project. We're on event tick right there. So if we go into our function, and mainly you see that I've got a trace. I'm getting the floor. I'm setting some values here based off the floor normals, and those become our float values for our pitch angle and our roll angle. So let's look at the graph here. First, I'm setting, we don't need that. First, I'm just checking, am I on the ground or am I in water? And so long as I'm not doing one of those two things, then that'll be true. And we're setting our slope variables to 0. Basically, we're just resetting everything. Basically, that means, am I in the air? Am I flying? Am I falling? Am I gliding? Am I jumping? I'm not on the ground anymore. So I don't need to be checking for any sort of slope values. So I just want to make sure that those are reset to 0. That way I can make sure that my character isn't being accidentally modified when they shouldn't be. Or if they're swimming underwater, I should say. Then we're doing a trace. So we're dragging out our character movement here, not that one. It's this one. And then we're just saying current floor for walking. And then we're breaking that. So we just drag that out, hit break. And then we can find the one thing that we want, which is our hit result. So we break out our hit result, we break that again, and we expand it. And then what we want are our two normals, our impact normal and our floor normal. So we do a little math here that I completely don't understand, but I know it works. So yes, do this. We want the dot product of the inverse cos in degrees. Oh man, Kismet math. You gotta be kidding me. As an animator, that's funny. Um, so we're getting a value of 1 on our z, we're doing that Kismet math here on our inverse cos in degrees, and then we're dragging that out, and that's our slope angle. Then we're getting our normal. We're getting, there's just a function here that says get slope, not that one, get slope 3 in angles. So essentially, you just want to find the floor normal. Bam, that's right there. Fantastic. Then you want to hit after right vector. Boom. Hit after up vector. And splash. And from there, we can pull those out and make our new variables. So we have our pitch, and then we have our roll. So pitching is kind of like if you're leaning forward or backward. So if we look at our character here, take a little screenshot. So pitching is looking at the character from the side, this way, this way. And likely this is a 0 standing straight up. I don't know off the top of my head, but this is probably negative, and this is probably positive. Probably. Then looking at the side of the character, so that was pitch that we just looked at. Same thing. We're tilting left, or we're tilting right. This is probably 0. This is probably negative, and this is probably positive. So we'll make our character stand like this or like that for roll, typically, and lean forward or backward for our pitch. Okay, let's go back to our function. We can see these values in play. So let's watch these values here. Watch. So right click on them and hit watch. Just drag that off over here. Not like that. There we go. And then I've got the BP pulled in for this character into the scene. So we got BP base player hero. And then we're just going to simulate here. Compiling blueprints. And I'm going to select the floor, move everything over, and I'm just going to rotate the floor. So these are not in scope, so I can't watch these, but I can print them. Let's do that. So I want to grab one more. I only have 2 here. Then I want to print. So what I'm going to do is say append. That way I know this is the angle. This one's the pitch. That comes here. This comes here. I'm going to say pitch, angle, which we'll pull from here. Connect this. And then I'll do the same thing here. Call this roll. And there we are. And one more connection. Whoops, I'm playing now. I need to simulate. Okay, let's simulate. So we're on a flat surface here. So we can see it's kind of there. I guess whenever I move my mouse, it goes away. So we have our roll. We have our pitch and we have our angle. Let's get brighter colors here. Oh, we're in it now. So as we rotate, you see the angle of our floor is 14 degrees, about 15 degrees. Our pitch is a negative 15 degrees, so it's the opposite. And we have no roll because we just tilted forward and backward. And we can see how our character is adjusting to basically try to fall over. So I have her adjusting to the opposite degree of the floor. So now if we go to roll, so if we go to the side, we've got rolling left and right. And we can see the floor angle changes too. So now once we have roll and pitch working together, we can see how the angle is a little bit different than our pitch. So those two things won't ever always be one and one. Yeah, simulate mode is fun. We move that over, have our character fall, and whatnot. Okay, sorry, just had to have a little fun there. Okay, so now what are we looking at? So this is in our blueprint. Let's disconnect this, stop watching these values. So we need to get this information over to our ABP, our animation blueprint. So let's click there. We're in our animation blueprint, and hopefully you all know this, but it's very simple. It's basically we're grabbing a reference to our blueprint. And once we grab that reference, we can pull in any information that's in that blueprint into our animation graph. So we are getting the pawn owner on initialize, and we're casting to our BP base player. I'm setting a variable there for base player. And then in here, you can use property access if you like. So prop access. We can grab the base player. We can come up here and start typing slope. All of our slope stuff is going to come up. So we can have our slope angle, pitch, and roll here. So you can just grab them there. So you don't actually have to create variables if you don't want. My project's pretty old. So somewhere in here, let's search here. I'm setting those variables. Probably one of the common variables here. Set common vars. Let's come here. Somewhere in here. Oh, look at that, it's at the very end. We're setting our slope here. So we're getting our base player, we're dragging that out, finding our slope angle, and then here's our slope pitch, and here too. So we're getting those, and then we're setting them into new variables for our ABP. So that's a couple different ways that you can grab your variables from your BP and get them into your ABP. So then the setup is on a control rig. So just somewhere in your graph, find a good spot. I like to do it before I'm calculating foot placement. So my foot placement node is here with leg IK here. So well before that, we have our slope control rig that we created. And in that control rig, we're exposing some variables that we're getting from our BP that we just set. So we're getting our slope roll, slope pitch. We're checking if we're strafing or not, because I wanted to do a slight modification to some values based on if we're strafing or not. And same thing, some slight modification to some values based on if we're moving or not, or what speed we're moving at. So if we go into our control rig, so let's find our control rig here. We can kind of set this up from scratch. So we come here, we're going to add, then we're going to find animation, control rig, control rig, control rig. You need to say it 3 times. I'm going to say control rig, HG, slope, tut. For tutorial, then we're just going to open it up. We're going to import, come over to rig hierarchy and import our SKM. It pops up right here. You just want to search for yours and hit OK. And then at the end of the day, what we're doing is we're setting our transform. So set transform here. You can also drag here. So we're going to drag the bone that we want. So I'm going to set the root. I'm going to say set relative transform. I'm actually not sure the difference there. So we're going to set, interesting, that's relative here. We don't get a set transform here. So anyway, set transform. Sometimes I'm flying blind and I don't know the difference between relative and set transform. I'll have to look into that later. So we just want to set the root here. Then we want to get the transform. So we want to get our root here. And we just want to drag that over to our value here. So we're not going to do anything here to our scale and translation. We just want to change our rotation here. So we want to change our rotation. So we see how we've got this quaternion rotation here. We want to go to oil. And then we want Euler. And then we're resetting our quaternion rotation there. Basically, this is a way for us to split out into our XYZ values. So what we don't want is to change our Z. So our Z, which I didn't talk about, so we can see that here, our Z is up. So we take a snapshot, we come here, and if Z is up, and we rotate around Z, like that, or in that direction, our character is just going to turn. So eventually, our character would be rotated this way, or this way. So we're pivoting around our Z-axis, like that. So we want that to be for our camera look. So we're not going to do anything to our Z value here. So I'm just going to double check over here and see if we're multiplying or adding. Okay, we're adding. So we want to add in our values here. We want to add. Right now we're not adding anything to X. And then we want to add not an array. We want to add maybe one of these times, third time's a charm. Add. There we go. To our Y. And then we can save this. And then we can just check what it is that we're doing here. So for 15 here, we can see that our X here is actually our pitch. We can tell that here because if we look at our X here, grab another screenshot. So if this our Z is up, our Y is forward and back, so our X is here, side to side. So if we rotate around our X, we will rotate forward or backward. So same thing with our Y. So if we're rotating around our Y, we'll erase these. We will rotate side to side like that. So our character will go away from us or come towards us, depending on how we're rotating. The same thing here. Let's zero this out and test it. We say 15 or negative 15 and see how she's rotating towards us or away from us. So that's fine that we can set those values, but we want to set those values based off the information that's coming through the game. So this will be a promote variable. Go to our blueprint. We'll say slope pitch. And this one will be a promote variable. We'll say slope roll. And on both of those variables, we'll need them to be instance editable so that we can pass values from our ABP to control what these values are. So let's compile, save, go to our ABP. Let's get our new control rig. We'll type control rig. We'll click on it and we'll find our control rig class. We want slope cut. And then we're going to expose our two variables here, slope pitch and slope roll. So here, they're right here. So we can say, we can just copy them. But if you didn't have them, then we can say slope pitch there. And here we can say slope roll. Nice. So we're going to pull that down here and connect our new control rig. We're going to compile. And then we are going to simulate and see how our character is affected here and see if we need to do anything else. So yes, we do. This is great if you want your character to align perfectly to the floor. So we can see that she's doing that here. So, but what I want is for our character to feel like she has to counter her weight to stay balanced. The same thing, we're aligning perfectly here. So let's go back to our control rig. What we want to do is multiply here for our pitch. And then we're just going to say, actually, let's do our roll first since we're looking at it. The same thing, drag out, multiply, and then connect our pins. We'll say -1 to get the opposite. So now we know for our roll, we are getting the exact opposite value of the direction that we're rolling. So let's look at pitching. So let's reset this. So if we pitch, same thing, we're getting the exact value, but now let's get the opposite value, -1. Now we're lying down. So maybe this is too extreme, and that's fine. what we can say is we don't want the exact value. Let's take a percentage of it. So negative 0.2. And if I was looking at roll, that'd be great, negative 0.2. There we are. So now we get just 20% of the opposite direction. We can see our character is trying to counter her weight based off the floor, pitch, and roll. Let's look at roll. Excuse me, let's look at pitch. So same thing. So that's great. And then you'd be done with your setup. And that's basically the entire graph. So the extra stuff I have we're looking at is strafing and ground speed. So I just wanted to make some, you can see here, we stopped here. So I'm just making some different values based on what state we're in the game. And this is where I think you can do some cool stuff. So I'm not sure what states you'll have in your game, but you can see how you might modify it. So I'm bringing in our bool for strafing. It's instance editable. And I'm just saying to, I think we can just pick it. I'm not sure if this is really interpolating or not, because once you're in it, you're just in it. So I'm not sure if I needed that. So I think we can say switch. Oh, I'm sorry. Select here too as an option. So if you're true, it's a value of 1. If you're false, it's a value of 0. So 0 for false, 1 for true. And then we'd hook this up here like that. And then we can just say our values here, which would be, actually I would not do these, which would be for strafing, I believe. This was negative 0.15. And this was a negative 2. I was playing around with those values. So we'd say here, if you're strafing or not, negative 0.2. And if you are strafing, we have a negative 0.15. So if I stop this and I play it, let's actually not do that. So if I rotate the ground first just a little bit, then we'll play, and then we'll start strafing. One thing first, I need to change one of my settings here for walking because it's using Alt and I'm Alt tabbing. Need to find it. Here it is. We're going to get rid of this left Alt there. Okay, compile. And I'm going to go ahead and save that. Save what we've done here. Also going to switch back to our slope, our original one, for our control rig. So now if we go to our control rig, slope warping, hit play, we're here, and now we're strafing. Now we're staying in strafe mode and we're alt tabbing. So let's turn our camera a little bit. We're here. See this one? Okay, cool. Let me make sure I have the right one. Yes, I do. Okay. So we're leaning still. We're strafing now. So now we're not strafing. We want to say, so 2, right? So we're not strafing. And then we come back and we say we are strafing. And then we want to say 2 here. And now you can see how this bool here is selecting a different index based off the state that we're in. And we can set different values for the different states that we're in. So you would probably want that for whatever game that you're in or playing. And then I'm doing the same thing over here for ground speed. So we're saying, am I strafing or not? I believe this setup was here like this. Come back over here. Basically, this is saying I'm getting a bool, I'm transferring it to an index, so a numerical value, a whole number, and then I'm transferring it into this float value. So it's still going to be a 0 or 1. So A is false, B is true. So if we're saying if A is false, then this sets this result here as a value of 0. So we'll be up here in our A. So that is our non-strafing movement. And then if we're true, will be a value of 1 here, which sets this result as a 1, which will be in B here. Now we are in strafing movement. So now, based off our ground speed, so we're piping in how fast we're moving into the game, we bring it into this remap node, and then we're clamping it. So based off that value, we're saying, what is our speed? My default run speed in the game is 730 units per second. So based off that speed, if we're stationary, so 0, we would want our normal value, 0.2. But if we're moving, we want a higher value of, say, 1. So let's see what that looks like. Let's pipe that in here. Actually, let's say 2. We'll come here. We'll go back to strafing, back to non-strafing, and then we'll start running. We can see how that is affecting our character movement. If we say, let's come back over here and say -2. So now we're really leaning away from the wall, or towards the wall, I should say, based off based off the fact that we're just moving. And then now we're stationary. We have different values here. So you may want to play around with that too, based off what the player is actually doing, and that modifies how the character is running around and moving and reacting to the world. I think that is a subconscious thing, but and a subtle thing, but I think it's a very impactful thing for the player experience. So let's recap. We have our slope trace here. We're using our normals for the wall or the floor that you're on to find the angle and to find the pitch and roll values. We're passing that information to our ABP via a cast from our blueprint. And in our anim graph, we're passing that information into our control rig. And our control rig is doing the math. And if we wanted to, we can test different joints. We wanted the pelvis to move. And see if that does anything. But it may not, but we're at the end of the video, so I'm not really going to test it out. So let's do -2. That is doing something. Great. So you can have this apply to different bones too, and see how you like it. So let's try the upper left arm here and here. There we go. So now you can add those on as you see fit too. All right, that's the end of my explanation of how I'm going through and setting up slope warping for my character. And hopefully now that empowers you to be able to add slope warping to your characters as well. So good luck, happy animating out there, and hopefully you'll enjoy that journey.